Okay, so today's topic is Introduction to the Script Element. My name is Ryan Roper. I've been here at GoldSim for about 4 years now. I haven't done many of these webinars, um, but we recently did a user conference, and actually I'll move to the next slide for this. We did a user conference recently here in Seattle, and I presented on the topic of script elements. I also presented on the topic of arrays, vectors and matrices, and it was actually combined into one presentation, and I ran out of time. It was just way too much material, and even the script element by itself is a big topic, particularly if we want to build up from the basics and work up to the advanced. And I'm going to try to strike a balance. People have varying levels of familiarity with the script element, and I advertise this as an intermediate level introduction to the script element, and we have to hit some basics at the beginning, just to make sure you're familiar with those basics, and then we'll try to progress into some intermediate examples, and finally we'll actually end on a fairly advanced example. I think it's fairly advanced, and it's based on an example that I shared in the webinar last month on introduction to arrays, and you can actually go to our website. I'll click on this link here. Let me make sure that's coming up. Let's see here. Well, I can always, I don't know. Oops. Okay, no. Let me just go ahead and we'll just go there this way. Okay, so if you go to resources, and over here on the left-hand side, webinars, and this is the one we're doing today. For a look at the past webinars, here's the one I did last month, and I would definitely encourage you to look at this. I talked about vector constructors, and I'm going to mention those today, and this is a great topic to know something about. Array constructors generically, but there's vector constructors and matrix constructors. So I'd definitely encourage you to take a look at that if you can, and then also, the future webinars, these topics here that are coming up in the first half of 2016 are all things that we talked about at the user conference, and we wanted to make this material available to more users, and so that's why we're doing these webinars to cover that material and make that available. So keep an eye on those, and there's probably some of these you'll want to attend. Okay. So like I said, we'll cover some script element basics. Variable definitions and assignments are kind of the most basic building block of a script in GoldSim. And I'll also talk about other basic aspects of the script element, such as loops, and I'll also talk about initial values. A script element has an initial value field, and I should make some points about that just for your information. And so I'll talk about that. We'll move into some examples that I'm calling them intermediate. They're kind of beginner to intermediate examples, and I'm going to introduce loops, specifically the for loop and the while loop, if then else statements, and I'll talk about using breakpoints to debug your script. Like I say, these topics, I think these are intermediate topics, but the examples we'll be looking at are just very basic examples, and actually they're not even things that you would, they're so basic you wouldn't necessarily use a script element for them, but those examples then become the building blocks for doing things that are much more complex. So I figured it was a good way to introduce looping, in a way that I think is understandable. And then we'll move into an advanced example that is based on this example from my Introduction to Arrays webinar last month, monthly and annual cumulative flows. I think it's an example that some of you may find useful, and if the specific application isn't necessarily something you need, at least the concepts required to implement a script for this application are probably generic enough that you could probably find ways to apply those to your specific use cases or applications. So right off the bat, just to mention some what I feel like are advantages of a script element, and I'm sure there are more, but these are the ones that I can think of off the top of my head. It's a very compact format to do complex calculations. You can just condense them down into a single script element and do several calculations, and then you can actually expose variables. You can create variables and expose them as outputs on the script element to use them in other places in your model. And so yeah, that's that second item here. And it's also easily scalable, particularly if you're having to loop over, say, vectors. It doesn't matter if you're looping over a 5-item vector or a 100-item vector. You're just executing the exact same set of calculations. You're just doing it more times. So it's not the same as if you had implemented some calculations using GoldSim elements like expression elements and other elements, and then you had to do that multiple times for different inputs. You'd potentially have to copy and paste those elements several times. So yeah, these are just some of the things I've thought of in terms of advantages of using a script element. So script element is very much like any other element, at least when you look at the top section, you specify a name and a description. And I would always advise putting in a description. It takes display units, and also the script element main output can be a scalar or a vector or a matrix, just like several other elements in GoldSim. And the bottom section here is the statement list, and that's where we'll be doing our work and where you will implement your calculations and other logic. And I think we can now take a look at a model. And so those screenshots that you just saw a moment ago are taken from this. Here I have a section of the script element here at the top where I simply define two variables, A and B, and give initial values to them. And then in this bottom section here, all I do is I do some calculations on using A and B, and then I assign the result to a variable called result. And I didn't create this variable. This is a variable that's built into the script element, and it actually corresponds to the primary output of the script element. So when you look at the outputs on a script element, here's A and B that I defined myself, but then you have this one here that has the same name as the element itself, and that's the one that result corresponds to. And so anything you assign to result, that's going to be the value of the main output of your script element. So let's actually create a script element. It's here in the functions list of elements. It's right here. And I'm not gonna give any name to it, but description of element. We don't need to do that, but and I'm just going to start out by creating a variable definition. And so here, if you didn't see that, there's this drop list right here, insert, and these are all the types of statements that you can insert into a script element. And you see here that there's also keyboard shortcuts. You can do it that way as well if you know them. So Control D would be to insert a definition. So we can do that. I'll just do it right now. And so when you do that, you get this little dialog where you can define the name of your variable. So we'll just say A, and description of A. I'm going to expose this as an output. You don't have to. If all you're going to do is use this variable internally inside the script element, then there'd be no reason to expose it as an output. But if you want the value of this variable to be available to the rest of your model, then do check this box to expose it. So I'll go ahead and do that. I'm going to give units of meters to this. I'm going to keep it as a scalar, and I'm going to give it a value of 5. Okay, so and then let's put in another one. I'll just do this more quickly. B expose. And I'm also going to give this one units of meters. I'm going to say 10 meters. Okay, so these are two variable definitions, and I'm going to show you one other thing. I'm going to put in a comment here. And I would really recommend using comments for scripts. If you've done a lot of programming, you know how valuable it can be to comment your code, because what appears easy to you right now as you're developing it, you think you understand. I mean, you do understand the logic and you're familiar with it, but when you come back to it in another week or a month, it may not make any sense to you. And so it's a good idea to comment. And so I'm just going to put in a basic comment here, variable definitions. And I inserted it here on the second line. I'm going to move that up. So you can just select the row and then click move up, and that'll move it up to the top. So there's our variable definitions section. I'm going to put in one more comment, and I'm going to say that this is calculations and assignment of result to script element output. So I'm going to do a variable assignment this time. So when you do that, you have this drop list right here that'll show you all the variables in your script. I defined A and B, but result is just one that's always there. I'm going to select that one, and I'm going to say A times B. And so here you see right off the bat, we already have a problem. It says it can't find element A. So what it's doing is it's actually looking for an element named A somewhere in your model. It doesn't know that we actually want to use this A right here that we defined inside of our script. So in order to specifically reference that one, that variable, you have to put a tilde in front of it, this little squiggly symbol. And that takes care of that one, so we'll do it also on B. So that takes care of that issue, but we still have one other issue, and that's that we have a units problem. A and B both have units of meters, so when you multiply them together, you have meters squared. And we're assigning that to result. And result, as I said, is the main output of this script element, and we define that unit here. So I'm just going to put in M2 for meters squared, and then tab out of that, and that'll correct that problem. And now if I hover over this, it'll tell me that the result is 50 meters squared. So that's just a very basic example to introduce you to variable definitions and assignments. I'm going to introduce you to something else right now, and to do this I'm going to actually create another script. If you're familiar with scripts, you may not necessarily be familiar with this, but I think it's something worth being familiar with. It's very useful, and that's down here at the bottom. You have these three items here, log message, log warning, log error. This allows you to write messages or warnings or error messages to the run log. And how is this useful? Well, let me just put it in, and actually let me just let me actually close this for just a moment. I'm going to create, and I didn't mean to cancel that, but oh well. I'm going to create a script element, and I'm going to have this resample on every time step. Unchanged eday, and I'm just going to leave it as a uniform 0 to 1 stochastic. And this is going to be resampled on each time step. I want to monitor the value of that stochastic, and I want to know when it exceeds a certain threshold value. So I'm going to put in a data element called threshold, and I'm going to give it a value of 0.8. And we're going to check, we're going to put in, actually in a script element, we're going to put a log message line here, and we're going to say, and in a moment I'm going to have to actually put this inside of an if statement, and I'll talk about that in just a moment, because what we want is we only want to show this message if that threshold value is exceeded. But let's first write what our message is going to be if we exceed that threshold value. So I'm just going to say stochastic 1 exceeded threshold value, and inside of parentheses here I'm going to put in a squiggly bracket here equals, and I'm going to reference the name of this element. So I'm going to reference stochastic 1 and a closing squiggly bracket. And what this is going to do is when GoldSim writes a message to the run log, it's going to replace this with the actual, oh sorry, not that one. We want it to be threshold, right? We're going to replace it. GoldSim is going to replace this with the value of threshold. So if ever you decide to change the value of threshold, you don't have to come in here and change some hard-coded value that you've put in here. So stochastic 1 exceeded threshold value, and then we're going to say value is, and then squiggly brackets equals stochastic 1 closing squiggly bracket. And so that's good enough, and I'm going to show you after we, let's actually put this inside of an if statement. So I'm going to select that line, because then when I insert this if-else statement, it's going to wrap that line, oh, no, sorry, it actually did it just below. So what we can do there is select that line and move it down, and it'll just put it right inside of that block. And we can have multiple lines inside of this block. We can, and we'll see examples later in the presentation of that. So we only want to show this log message if we do actually, if stochastic 1, the value of stochastic 1 does actually exceed threshold. Otherwise, it'll just ignore this line and nothing will be written to the run log. So let's run this, and let's go look at our run log. That's in run, and then view run log. And here's what we get. So on day 3, we see that stochastic 1 exceeded the threshold value of 0.8, and the value of that stochastic is 0.938, and so on. And we see several, we see that happens several times throughout the simulation. And so this is something that, you know, if you want to monitor anything in your model, and this is just one application of using for logging messages, but I think it's probably a fairly typical case if you want to monitor the value of something in one or more things in your model. Then you can just have it silently write to the run log, and then after you've run the simulation, you can go and look at the run log. Okay, let's move on here. I want to talk about initial values. So I'm going to open up a different model. Okay, so the initial value, in this case, right here, I'm referencing this data element here. You can hard code a value into there. I've just decided to link it to this data element. So point number one that you need to know about this needs to be a static value for a given realization. So in this case, it's a data element that's going to be the same throughout the simulation in time and also over the course of different realizations if you have a multi-realization simulation. Let's say I linked to a stochastic. As long as that stochastic element is resampling just on each realization rather than on each time step, this will that's good enough. GoldSim will treat that as a valid initial value, and so that way you can actually have different initial values for each realization. So point number two, this is the initial value. Okay, so backing up just a moment, a script element will be updated just like every other element. It'll be updated on each time step. Time 0, then time 1, time 2. But this initial value is just the starting value at time 0, and thereafter you can say on time 0, in this case, it's going to take that initial value and add 5 to it and then assign that again to the output of the script element. So on this first time step, we're going to get a value of 10. But what's going to happen is on time step 1 and time step 2, each time it's just going to, your script element already has the value from the previous time step, and it's going to reuse that. And so if you add 5, it's going to keep adding 5, and it's going to accumulate that, and it's going to increase linearly throughout the simulation like that. So it remembers its value from the last time step. If there's ever a situation, and the reason I bring this up is because I had a customer asking about this, if you ever have a situation where you would like to redo the calculations each time step, you don't want GoldSim, you don't want the script element to remember its value from the last time step, all you got to do is just put in a line here where you explicitly set that value back to the initial or some other value on each time step. And then in this case, what we'll do is we'll start it out at 5 on each time step. We'll add 5 to it and save that value. So when you look at this, it's just a constant value. So just some things to be mindful of, nothing particularly complex. Okay, so now let's go into our looping examples. And again, like I was saying before, this isn't necessarily a situation where you would want to use, this isn't an actual application where you'd want to, it's kind of a contrived example, I guess, but it's more for educational purposes. But we will, when we look at our advanced example, we will see something where a script element is very much the kind of thing that you'd want to use. But for this case, if you're not familiar with vector constructors, I'll just briefly describe this to you. You can take, say, an expression element, and you can, if it's a vector, you can put this this expression in that expression element, and what it will do is just populate that whole vector with values going from, well, this row, this is a keyword in GoldSim, and it just corresponds to the index value in the vector. And so for the first index in that vector, it has a value of 1. You multiply it by 1 meters. So in the first location of that vector, you'll have 1 meter, and then so on, 2 meters, 3, 4, and 5. So let's go ahead just to show you how to use a while loop. Let's just use a script element to do that. Okay, so here's that expression here. You can see in the tooltip, but I'll just open it up. So here's what you just saw in the slide, and all that's doing is populating this vector with values 1 meter, 2 meter, up to 5 meters. Here I have a while loop, and what we've done here is we have our variable definition section and I've defined a variable called max. And all this is I use this built-in function called getRowCount, and then I reference the script element itself. So this is a script element of 5 items long, but I could change this array label set so that it's 100 long, and that wouldn't break this because we're using this getRowCount function, and we're getting the size of this script element. So that's a kind of a useful little trick. So this tells us the size of the vector because we don't want to iterate beyond the end of the vector. And for a while loop, we're going to need some kind of, so a while loop is, here's an example of one, and what it's going to do is it has a set of instructions here, but it's only going to go into that loop if we satisfy this condition that we specify here. And actually, when I double click on this, you see this dialog, and this is where you can specify that condition. I've just said that as long as row is less than or equal to max, let's keep iterating through this loop. And so row is going to start out at 1. It's going to enter into this loop. And what I'm going to do here is I'm going to assign a value to result, but result is a vector in this case. So we're going to choose this option to assign a value at a specified index. And that specified index is just this row index here, and then the value that we're going to assign at that location is just that index times 1 meter. Just for your information, another way to assign values to a vector variable in a script element is the entire array all at once. And in that case, you would only have one field here. You wouldn't have this field here. You just have one field, and that field would have to contain a vector constructor so that you have all values needed to assign values to the entire array. So then probably the most important line here in this whole script is this one here, because we need some way of eventually not, having this this statement become a false statement. So I'm gonna increment row each time we loop through this, and eventually we're going to get up to a point where row is greater than max, and that'll cut out of the loop. And so be mindful of that when you're using a while loop. You need to make sure that there's some kind of logic inside of this, inside of the block, the while loop block, that makes it so that eventually that'll become a false statement and it'll cut out of the loop. One situation where you might want to use a while loop is if you're doing some iterative calculations where you're gradually converging to a desirable value or desirable result, and you need to keep iterating until, say, you reach some threshold, small value, below which it is, say you're comparing the new value to the previous value, and you want to iterate until it stops changing appreciably. So you'll put a condition in here saying that difference, while that difference is greater than some threshold, keep going. Once it drops below that value, then we've converged on a good solution, and we'll stop the looping. Okay, so for a for loop is actually better suited for this specific situation here, because we know the size of the vector. We know how many times we want to run through the loop. It's always just the size of the vector. And so in this situation, a for loop allows you to specify a certain number of iterations. And so again, we're going to have this line where we get the size of the vector using getRowCount. But here, I'm going to double click on this to edit it, or I could alternatively just click down here and click edit. So for a for loop, we specify a looping variable, and I could have called this anything. I could change it to IDX and tab out of there, and it updates this. So our index, it's going to start at a value of 1, and it's going to increment by 1 on each loop. And we're going to keep looping until while that index is less than or equal to max. So similar to the while loop, except that we specify the condition, the stopping condition here, and we also don't have to keep track of the value of some counter. And so now we only have one line in here, and this we're doing the same thing as we did last time. So at index location IDX, give this value. And this could be any sort of complex equation here. That's not much more complex, but that just gives you an idea. You can do anything you want in here. But in this case, what we were aiming to do, if I run this, now that guy is actually 6 through 10 because I added that 5. But anyway, so there you go. That's just a quick introduction to loops. There's other types of loops, and I'll just briefly mention those. Let me just create a script element. So here's a for loop, the while loop. There's also a do loop, which is in the GoldSim script world. A do loop is actually very similar to a for loop. There's something in programming languages called a do while loop, and that I would say more or less the equivalent of that in the GoldSim scripting world is repeat until. I'll just mention that in a moment, but let me just show you a do loop. So a do loop, as you see, it's very similar, except that in this case, for the for loop, let's see, it seems like we specified a condition once, once our looping variable was, while our looping variable was less than a certain variable value. Actually, we could do something very much the same. This doesn't have to be a hard-coded value. We could do something, I think, pretty much the same as we did with a for loop. But anyway, so yeah, you see that this is very similar to the for loop. We have a variable or an index here, and we have a start value, increment by, and an end value. How about the repeat until loop? This, what you see here is in a way it's similar to a while loop, but we only test the condition after we've executed the statements inside of the loop at least once. So a repeat until will always execute at least once, and then it'll check the condition. If that condition is not met, if it's false, then it'll break out of the loop. Whereas a while loop may not ever execute at all, because you test the condition at the very beginning of the loop, and if you don't satisfy that condition, it'll just jump over the whole thing, and it won't execute at all. So if you have a situation where you want it to for sure execute at least once, and then possibly not thereafter, then use a repeat until loop. Okay, and let me just make sure that I didn't miss anything on the script element, so we've talked about variable definitions and assignments. We talked about all these loops. I did show you an if-else statement, and you'll see more of that in a little while. We did comments and then logging messages. I didn't mention these. Let me just mention that briefly. If you want to, so this is going to loop, in this situation, this is going to loop 5 times, but let's say we meet a condition. Let's say our application is different than what we're doing here, because this was just kind of a contrived, simple example. But if we have, say, a different set of instructions in here or calculations, and if there is the possibility of you wanting to cut out of the loop early before you before you satisfy this condition. You can actually put in a break statement, and you would want to put this inside of an if-else statement. So the if-else statement would be used to test a certain condition. If that condition's met, then go inside of that if statement, and if you have a break statement in there, then that'll tell it break out of this while loop. And a little bit different but similar concept here is a continue statement. What you would use this for is if, again, you'd want to put this inside of an if statement. And so if a certain condition is met, and it goes, if you go into that if statement and you have a continue statement, what that tells GoldSim when it's executing this statement list, what that tells GoldSim is don't execute all the, here, let me just put this in. I'm going to put it in, maybe easier if I just put this in. I'm going to move it up. I'm going to put it inside of an if statement. So I'm not going to put a condition in here, but you would need to put some condition in there. And then, sorry, I'm going to move this down and move it down inside. So if this condition is met, go in here, and when GoldSim sees this continue statement, that tells GoldSim, don't execute the rest of this block of instructions that's inside this while loop. Go ahead, just skip over them for that iteration and just start over again at the beginning of the loop. And so that off the top of my head, I can't think of a specific situation, but I'm sure there you may run into a situation where you'll want to do that. Okay, one other thing before we move into our advanced example is here's another thing I can tell you about. If you want to delete anything, you can delete one row at a time. So if I just highlighted this and click delete, it would just delete that one row. Or I could actually highlight a whole set of rows and click delete, and it'll just delete that whole thing out of there. I'm going to show you now how to use breakpoints. And breakpoints are a concept that you'll be familiar with if you've done any programming in a development environment. So say Visual Studio or something like that. If you've done any programming with that, you can put in break statements, and I'll put one in right here, and all you do is you just highlight a line and then you press F9 on your keyboard, and that's going to highlight that in this pink color. And what that's going to do is that when you run your model, when you run your simulation, and you'd want to do this when you're having a problem with your script element, it seems to be giving results that don't make sense. You may want to put in one or more breakpoints, and then then close out of this. And then when you run your model, I'm just going to press F5 to run the model, or well, I'll need to do it twice here. So at time zero, when it went to update this script element, it executed all the way down to here, and then it stopped on this line because I put in a breakpoint. And so this is just the first pass through this set of instructions or statements in this script element. And so what I can do is I can kind of probe around and say, okay, well, and this is a very simple script here. You'd likely be doing this in a much more complicated script. But you can open up one of these and you can say, okay, well, what's the current value of row? Let me just click on it. Okay, it's 1 right now. Okay, well, let me step now through by clicking this button here. If I step through, you see it now this one that has a bold outline on it is where that's the line that it's on. So we've just now passed this line. Well, what happened when we did that? The row was incremented to 2. So we can step down through, and let's say we step again so that we're back to the beginning here. Now this has incremented to 3. And now you see that if you had a whole set of instructions in here, you could just go down through line by line one at a time, and you can kind of look around and say, okay, is this updating to a value that I was expecting? If not, okay, I see where I went wrong here. I need to, make a change here, and so you can debug that way. If you once you're done with it, you can just press F9 again. You just highlight the row and just press F9, and it'll undo that, and then you can go on your way. So definitely make use of that. Keep that in mind when you're pulling your hair out trying to figure out why your script element's not working. Here's a little bit more, slightly more advanced example. I'll talk about this briefly, and then we'll go into the example that I've been talking about from my last webinar. So let me just show you this real quick. So here's a situation where we have nested an if-then-else statement inside of a for loop. And what we're doing here is, again, this is just like our other for loop example. We're iterating over this 5-item vector. But here we're saying, instead of just assigning this value of, row times 1 meter, if row is less than 3, I want to assign a different value. And in this case, we're just going to assign a value of 0 meters. Else, assign a value from this other element. This is also a vector, and it does have values 1 meter, 2 meter, up to 5 meters. And so what you get in this case is, when I just ran the model, I'm hovering over this, you get 0, 0, and then 3, 4, 5. And so that just illustrates how you can nest if statements inside of loops. You can actually nest loops inside of loops, and the example I'm going to be showing you in a minute does that. And one other thing I wanted to mention, you may be wondering, how did you, let me put this back in edit mode. How did you put in this else clause here? So I'm just going to click on this, and I'm going to double click on it to open it up to edit it. If you didn't see it before, you can actually check this checkbox here to provide else clause. If I were to uncheck that, then this bottom half, these two lines would disappear, and you just have an if-then statement. But if you want, if you have a situation where, here in this if statement, if this is satisfied, you want to execute this line. But let's say this isn't satisfied. Maybe there's something else you want to do in the case where that's not satisfied, and that's where you'd use an else statement. Okay, now into the real interesting example. Okay, so I'm just gonna open this up. And this, this is from my last webinar. I also talked about this at the user conference. But as background here, for now, just disregard everything up here. I'm just going to talk about this part down here. So I have a stochastic here, and I called it flow, as units of liters per second. And this stochastic actually resamples on every time step. So I've chosen the option to resample, and I'm resampling on changed day of month. And I have some autocorrelation. So what you get when you run this, if I plot this, is this that bounces around. And like I say, these are flows, but what if what you actually want is to know how much, say this is water flow into a reservoir, you want to know the total volume amount that flowed into a reservoir each month. Well, in GoldSim, if you haven't used these, if you haven't used reporting periods, you can do this with reporting periods. And so here I've just gone into the time settings, and I specified major and minor reporting periods, annual and monthly. And what this does is, I'm just going to open up this time history element. You can actually, I'm in result mode right now, but if you were in edit mode, you can actually change this time display setting. I've already changed it. It says reporting periods, but you'll want to set this to reporting periods. And then what that does is, if you were in edit mode, you'd see a little drop list arrow here, and you can select, let me just actually show you this. So I'm going to go back into edit mode. Here you can select, I've just connected up this stochastic twice, and in one instance I've chosen the option to show all plot points. So this is just going to show those actual flows. So it'll have units of liters per second. But here I've, again, referencing flow, I'm actually going to have GoldSim, or the time history element here, calculate cumulative amounts. And so this is going to act like an integrator, but it's going to just integrate over these reporting period intervals, so over monthly reporting periods and over annual reporting periods. There's other options here. You can have it calculate average over that time, or change over that time. But here we want to know the total volume amount that came in each month, and actually it's also going to calculate the volume amounts that came in over each year. So when I run this and I look at this plot here, what you see is the green is the actual flows of the from the stochastic, and then this shows also those monthly volumes. And so for the red line here, you should actually be looking at this side here, and this is cumulative flow in units of volume units, megaliters. For the green line, you want to look over this axis. Flow is in liters per second. So if you look at the table view, you can see these are those volumes. So in January 2015, this is how much came in to our reservoir. And the next month, this is how much came in. I can actually switch this to major, and the major reporting period, I've defined that to be annual, and so here for 2015, 2016, and 17, we have the total amounts over each of those years. So this is extremely helpful, useful for, I think there's many customers or users who've liked this feature. But one thing about it is that this is just for viewing. You can just view the results, and you can't do any subsequent calculations. So what if you wanted to, actually a vector of these volumes, like let's see, a 36 item vector with these volumes, so that you can do subsequent calculations. Well, that's what I've done here with this integrator element. And again, this isn't related to script elements, but I'll show you that in a little while. But here we're just using vector constructors to do all this stuff. And here, this is a 36 item vector. So this is for all the months in our simulation. It's a 3-year simulation. And our rate of change has to be a vector, because the result is a vector. And so what I've done here is I also have, let me just show you real quick. Oh no, never mind. So okay, so I have another element in the model here in this container called month count, and that just at any given time in the simulation, that tells us the month that we're in. So we start at 1 and go through 36 to the end of our simulation. And so when we generate this rate of change vector, we're going to load it up actually with all zeros, except in the instance where the row index is equal to to the current month that we're in. So say we're in month 3, then we're going to, the row vector is going to have the value of flow at that location, that third index location, but all the other values in the whole vector are going to be 0. And so during the third month, the only thing that's going to be changing in the value the value of this integrator is that third item. We're going to be accumulating for just that third month, and then once we go into the fourth month, then it's going to start doing it, accumulating for that fourth month. And if that's not very clear, this kind of illustrates that. So in the first month, here we're accumulating, and then we stop accumulating. Here in the second month, the second item in the vector is accumulating, and then it stops. And so what you end up with at the very end, if I scroll down to the very bottom, are these monthly values. And if you can remember any of the values you saw before when we were looking at the reporting period results, the first one is 2.92 and the second was 2.24, but we've now done it, we've calculated it ourselves using an integrator element instead of using reporting periods. And you can actually see it in this array view right here. There it is. And that actually matches our monthly totals calculated using reporting periods, which is right here, 2.92, and you see those match up. So now what's useful about this is that this can be used downstream for subsequent calculations. And so in here, I've calculated monthly statistics, and I'll just show you briefly how I've done that. And I haven't used script elements for this, but the reason I'm giving you all this background is because I'm going to show you now how I've used a script element to do all this. And but just real quick, this integrator right here, you don't have to understand. I'll provide all these models for you to download, and you can look at how I did this. But I have this is a 36 item vector. But what it does is it stores the year for a given month. So the first 12 items in there will be 2015. And then we go into 2016 on the 13th month. So 13 through 24 will be 2016 and so on. And so in here, what that allows us to do, which is kind of nice, is that here, let's see, say for monthly totals, this actually is only for 2015, and actually we can look at the results. We can look at these values here in this array view element. So if I open this up, what I've done here is I've just collected the values for just the first 12 months. That's 2015, and all the others are 0. And a similar idea to what I showed you in the before with the integrator element. I've done this with a vector constructor, where as long as that year vector that I just showed you a little while ago, if at a given row index location, it's the year is 2015, then grab the monthly total for that month, and otherwise just put in a 0 value in this vector. And so yeah, what we get is this just the values for the first year, and then the zeros for the others. We did something similar for 2016. There's that. We did something similar for 2017. There's that. But what we can now do is say we want to know the max just for 2015. Well, we can use a built-in function here, max v, on those monthly totals, and grab just the max value for 2015, which was 3.076. Max value for 2016 is right there, and so on. I also did year totals using a built-in function called sumv to get the total for a whole year. And here you see 31.178. Well, actually, we saw that in our reporting period results down here. There's that 31.178. But what we've done is we've calculated that ourselves. This allows us to do whatever other kind of post-processing we want to do. So one limitation of this is that we only have 3 years in this simulation. Well, what if we wanted to do this for 5 years or 20 years or 100 years? This isn't a very scalable way to do this, because I just have to keep copying and pasting these, and it'd become cumbersome. And it's unnecessary if you know how to use a script element, because we can do all this in a very compact way using a script element. So that's kind of the culmination of all of this, what we've been building up to. And so I'll just show you this. And we're going short on time here, and you probably wouldn't want to have to listen to me describe in too much detail, line by line, how these scripts work. I'd rather, I'll talk about it briefly and I'll show you, but I'd rather provide this model for you to download and actually study these scripts and get a feel for how it works, and then try to think of some applications where you might be able to do something like this. And it might be useful in situations, if you're a CT modeler, if you use contaminant transport, you always have a vector of species, and there may be things that you want to do, calculations you want to do over all those species with their concentrations or masses or something else. But also, scripts aren't just for iterating over arrays, over vectors and matrices. They're also for doing iterative numerical calculations where you're trying to converge toward a certain solution, or any number of other things. And hopefully there's some things that come to mind for your own applications. But let's just go into this, and here I've used a script element. I have a few script elements here. Here I've just done everything that I just showed you that we did with expression elements. I've calculated totals, yearly totals, with a script element here. Here I've calculated max values. Here I've calculated year averages, and there may be other statistics you want to do, calculate. Here I've actually just collected all of these into one, and not to overwhelm you, I'm not going to talk about this, but just to show you, how you can actually collect a lot of calculations into one script element. And this isn't that big and that complex of a script, and yet it's doing a lot of fairly complex stuff, and it's all collected into this one script element. And you can also, as I showed you before, you can expose variables as outputs on the script element. So these right here, I think I've actually exposed all of them. So here I've calculated totals, averages, max values, and I've exposed all those, and look at that, you have this all available to the rest of the model. So if I expand this out, here's the averages for these 3 years, max values, totals. I did counts also. I think I used that to calculate averages. I could have hard-coded a 12 value into that because each year has 12 months, but I did it using some script element logic in there. But this is really powerful. And one other thing I'd like to just mention to you is I talked about scalability before. With the other approach we used with the expression elements, like I said, you'd have to copy and paste. If you wanted to lengthen this simulation to 20 years or 100 years, imagine doing the work for that. Here, in this case, all you do is, here, I'll just go into this year totals example. And I have a loop within a loop, because what we're doing is this outer loop is going to loop over the number of years that you have. So this loops over starting with 2015, it loops increments by 1, and it loops up until we get to start year plus number of years minus 1. That'll give us 2017. So it iterates over 2015, 16, and 17. But all you have to do is change what the number of years is, and in this case I've gotten the number of years by the same way we saw earlier with get row count and then referencing this script element, year totals. Well, all I have to do is if I went to the simulation settings and set it to go for 20 years, all I'd have to do is go and modify this array label set, years. You can access it here. Say I want, let's see. Well, okay. I think you have to go into the main array label set editing dialog up here, but you just edit that year's array label set to have 20 years. And then, you know, this script element would be pretty unfazed by that change because it just uses this get row count, and this would tell you that, or this would actually set this num years to 20, and then our loop would go for 20 years. And so in each one of those years, I have this inner loop that iterates over all of the monthly values, and it says, okay, is that monthly value, does that correspond to the year that I'm in? So on the first pass through this outer loop, the year is 2015. So if the year for that month is 2015, then we're going to add our total to this running total here. We're just going to keep going, and so for each month in 2015, we're going to add something to this. Otherwise, we're just going to skip over this block. If we're looking at a monthly value that's in 2016, we're not even going to enter this if statement. We're just going to skip over it, and so that accomplishes what we saw earlier. We did with the vector constructor. And then we store this is just a temporary variable total. We store that in our totals vector, and then we reset the total to 0 for the next pass through here. And so yeah, I'll provide this example for you to download, and definitely look it over and try to understand how it's working, and then more importantly, start thinking about how you think you might be able to use script elements for some of the more bothersome calculations in your model that may require a lot of elements, or that you think you might be able to do in a more compact way with statements in a script element. I think that is it. Let me just make sure. And I'll also provide these presentation slides for you to download. But yeah, definitely take a look at that when it becomes available. So yeah, so are there, do you have any questions? You can either type the questions in, or you can click the raise your hand button, and I'll unmute you, and you can ask the question.